In this video, we are going to see working principle and operation of DC generator. An electrical generator is a rotating machine which converts the energy from mechanical to electrical. DC generator it works on the principle of electromagnetic induction. According to Faraday's law of electromagnetic induction, when a conductor is rotated in the magnetic field to cut the magnetic lines of flux, an EMF is induced in the conductor. This EMF causes a current if the circuit is closed, and that EMF is directly proportional to three parameters. One is flux in the magnetic field, another one is speed of rotation of the conductor, third one is total number of armature conductors. Next, I have taken two-pole DC generator. The outer part is called as field system, which is going to generate the magnetic field, and the interior portion, that green color, is called as cylindrical rotor, and it is going to rotate because it is mounted on this shaft. The conductors or the coils are arranged on a cylindrical rotor called an armature. The armature is rotated in the magnetic field so as to cut the magnetic lines of flux. To rotate this armature, another rotating device called a prime mover is used. The prime mover may be diesel engine, steam engine, turbine, or any other devices like this. So that prime mover is going to couple with the shaft. So while rotating the prime mover, along with that shaft and the armature portion is going to rotate. Thus the mechanical energy is converted into electrical energy. Hence, the essential parts of DC generator are magnetic field system and the armature. We have to see the simple construction of generator using slip ring, and here in DC generator the magnetic poles are made stationary. So these two are magnetic poles, this is stationary, and this center portion is called as armature, and it is going to rotate in between the flux lines. The armature conductor is connected with the slip ring. These two are called as slip ring. So each conductor is connected with individual slip ring. But usually in generator, according to the working principle, the EMF is going to induce. That induced EMF is always alternating nature. We have to see how it is alternating. But in this construction, I have connected slip ring. The slip ring is nothing but is a mechanical device that transfers electrical power from stationary to rotary systems and vice versa. Main function of a slip ring is to simplify the operation of system or improve mechanical performance by transferring the electrical power or signals from the stationary part of the machine to where it is needed on the rotating part. See the armature, here the armature is rotating. So this, from this we are collecting the EMF through the armature conductors, and this armature conductor is connected, if we can't directly connect with the static load because it is rotating nature, right? It is physically it is rotating. So we can't simply connect with the static load. So we need one mediator that is called as slip ring. So simply it will transfer that energy. That's all. Now we have to see how the generated EMF is alternating. We have to see the working operation for 0 to 180 degree. So in this construction, now I am giving mechanical energy. So before that, due to the DC supply in the field system, the magnetic flux are moving from north pole to south pole. And also, I have taken one assumption, that is the shaft is going to rotate in clockwise direction. Along with this, armature is also rotating in clockwise. So now what will happen? If you are seeing this end, it will move upward, and here the motion is downward. And according to the Fleming right hand rule, I have taken the position likewise. Bottom side also I have taken like this. In the upper side, according to this, we can verify the direction of the parameter which is there in the first conductor, that is in the red color conductor. So here the forefinger pointing the direction likewise. It seems the magnetic flux lines around the first conductor is flowing from north to south. Yeah, it is correct only. And after that, the thumb is pointing upward direction. The meaning is motion of the first conductor in upward direction. Okay, that is also verified. And the middle finger should point the induced current. According to this view, the middle finger pointing downward direction. So it seems the current through the conductor, current in the first conductor, that is in the red color conductor, it should be in downward. Okay, so you have to see in the red color conductor the current is downward according to this view. Okay, and you can verify the similarly all the parameter in the second conductor also by using this view. Okay, so here the current is pointing upward direction. That is why the arrow is drawn like this. Clear? And so if you are tracing this arrow direction till the load side, what will you get? See, the current is in the red color conductor, current is downward, and the same conductor is going to wound over the this end also. But to differentiate this, I have given different color, this side red color and this side black color. So the same current will flow likewise, and it is wound and it will circulate around this corresponding conductor, and it is taken out according to this rule, Fleming right hand rule. Then it is taken out through the brush contact, and through the load it will flow from Y to X in 0 to 180 degree. Next we are going to see the working operation from 180 degree to 360 degree. During this interval, due to the further clockwise direction of rotation, the armature position has been interchanged. So that is why the black color conductor is placed nearby the south pole, and the red color conductor is come across the north pole during this interval 180 to 360 degree. Now I am going to apply Fleming right hand rule to verify the direction of current in the first conductor. For that, I'm going to keep the position likewise. Magnetic flux in the first conductor is north pole to south pole. That is why this finger is pointing likewise. And the motion of the first conductor is upward. That is why the thumb is pointing in upward direction. And the middle finger is should point the direction of induced current. Now, according to this view, it points the downward direction. Here in the first conductor, the current flow direction is downward only. If you are tracing this direction along with the load side, the current flow direction in the load is x to y. But in 0 to 180 degree, the current flow direction in the load side is y to x. So it seems the current direction has been interchanged. That is why if you are using slip ring, the output of the generator is alternating nature. But in DC generator, we need direct current. That is why to get direct current, we have to replace that slip ring by a split ring. The another name of split ring is called as commutator. This is the DC generator with the split ring concept, and this is the split ring, and the split ring is mounted around the insulated disc. First of all, around the shaft, the insulated disc is accommodated, and on their surface the commutator segment is placed. There are two commutator segments. Both the commutator segments are insulated from each other by a mica, and brushes also accommodated in their commutator surface, and through this we are taking the electrical energy and it is given into the load. Now to explain the working operation, I am going to show the schematic diagram. This is schematic diagram of DC generator, and this is for one half rotation from 0 to 180 degree. Here, this figure shows the armature connection with the split ring. And there are two conductors, right? AB and CD. In the previous diagram, we have taken two different colors. One is red and another one is black. So, likewise, I have taken. And additionally, along with that, I have named that conductor terminal AB and CD. And it is connected with the commutator. There are two commutators. One is red color and another one is black color. The two commutator segments are insulated from each other by mica material, and the brushes are mounted on the each commutator. Through the brush contact, we are connecting the load resistor. Now we have to see the current direction. According to Fleming right hand rule, the current direction is likewise. So if the current flow direction is likewise, and it will flow likewise, and it will reach commutator A, then through brush B1 it is coming out that current, and through the load the current flow direction is X to Y, right? And after that, through the commutator B, it is returned back to second conductor. So it will make one closed loop. This is for one half rotation. And for another half rotation, you have to see the coil sides are interchanged. So the black color, the conductor is came here, and the red color is this side. Now again, the current direction is same only. Okay, the first conductor, the current direction is likewise, and the same current is enter into the commutator B, because while rotating along with the conductor, the commutator segment is also rotating, because it is also rotary device, and the current direction is likewise. Through the load you can see the current is flowing from X to Y only. Okay, in the second half rotation also we are getting same current direction. So it seems if you are using commutator, we can get direct current. This is the working operation of DC generator. I hope you all understood this concept. If you have any queries or comments, post it in the comment box. And thank you for watching this video.